Assalamualaikum and hi everyone. 3.2 Absolute Values. Cost framework for absolute values. A. To define absolute values. B. To state and use the properties of absolute values. C. Define modulus x equals to A and solve linear equation. D. Define modulus x less than A, modulus x less than n equals to A, modulus x greater than A, and modulus x greater than n equals to A, and solve absolute values linear inequalities. Definitions of absolute values. Sometimes absolute values of a number is described as the distance from the origin to the number on a number line. Modulus x is the distance of x from 0. For instance, since both -2 and 2 are 2 units from 0, we have modulus -2 is equals to 2 equals to 2. An example here, we have 4. So the distance between 0 to 4 is 4. Okay, and the distance between 0 to -4 also 4. So absolute values is the distance from the origin. Note, the absolute values modulus x of a real number x is defined by modulus x equals to piecewise functions x if x is greater than n equals to 0, negative x if x less than 0. So please remember that modulus x can be written as these piecewise functions. Number 2, the equivalence of absolute value also is modulus x equals to surd x squared. Properties of absolute values. First, we have modulus a greater than n equals to 0, where all the absolute values will be always positive and equals to 0. Example, we have modulus 10 equals to 10, which is greater than 0, and 0 also equals to 0, greater than n equals to 0, whereas we have modulus -10 equals to 10, which is also greater than n equals to 0. And then we have modulus -a is forever equals to modulus a and equals to a itself. Okay, modulus -3 equals to 3, modulus 3 and equals to 3. And then we have modulus a plus b equals to modulus b plus a. For example, we have modulus -4 plus 5 equals to modulus 5 plus -4, which is equals to 1. And then we have modulus a minus b equals to modulus b minus a. For example, we have modulus 6 minus -2 equals to modulus 8 equals to 8. And then if we have modulus -2 minus 6 is equals to modulus -8 and equals to 8. Okay, then we have modulus AB equals to modulus A, modulus B. We can separate into separated modulus. For example, we have modulus 7 times -9, which is -63. 63 itself. If we have modulus 7 times modulus -9, which is modulus -9 is 9, so 7 times 9 is equals to 63. And then if we have modulus A over B, also can be separated into modulus A over modulus B, whereas modulus B cannot equals to 0. So if we have modulus 12 over -3, this is equals to modulus -4, which is 4. And then we have modulus 12 over modulus -3, where modulus -3 is 3, so 12 over 3 will be 4. And please remember, modulus A plus B does not equals to modulus A plus modulus B. It cannot be separated. Same goes to modulus A minus B does not equals to modulus A minus modulus B. So let's go to example 1. Write the following without the absolute value symbol. So we have this expression, modulus A plus 5. So as we discussed previously, this can be written as piecewise functions. Remember? So we will have first a plus 5 positive, and then we have negative a plus 5. So for a plus 5, this is belong to a greater than n equals to -5, and this is the opposite, a less than -5. So how did we get the -5? Because we take all the things inside the modulus equals to 0, so we have a equals to -5. This is the critical value that we must put into our interval. And then we have modulus 2x minus 1. Modulus 2x minus 1 can be written as first positive 2x minus 1, secondly negative 2x minus 1. So how to get the critical value? So 2x minus 1 equals to 0, x equals to 1 over 2. So for positive, x will be greater than n equals to 1 over 2, and negative is the opposite. Previously, we discussed about the expressions of modulus, where can we separate into piecewise functions. So now we have equations involving absolute values. Geometrically, modulus x equals to a. So a is always greater than 0. Represents the distance of x from the origin is a unit. So therefore, modulus x equals to a is equivalent to x can be equals to a, or x can be equals to negative a. Okay, take a look at these questions. Example 2. Solve the following equations. A modulus x plus 3 equals to 6. B modulus 4x minus 3 equals to 9. Let's solve A. Okay, for A, we have modulus x plus 3 equals to 6. First, we must separate this into 2, which is the first one is x plus 3 equals to 6, or x plus 3 equals to negative 6. And then we settle this. So 6 minus 3 equals to 3. And this one is x equals to negative 6 minus 3 is negative 9. So our answer is x equals to 3 and x equals to negative 9. For B, modulus 4x minus 3 equals to 9. So again, we need to separate the modulus into first positive 9. Secondly, 4x minus 3 equals to negative 9. Okay, so then we find x. For x equals to 12, so x equals to 3. Secondly, for x equals to negative 6, x equals to negative 3 over 2. So answer here is x equals to 3 and x equals to negative 3 over 2. Example 3. Solve the following equations. A modulus x minus 4 equals to 8 minus 3x. B modulus 5x plus 3 equals to 2x plus 9. So this is absolute equation. So remember, we must separate this into 2, which is first positive right hand side and secondly negative right hand side. Okay, so let's discuss A. Modulus x minus 4 equals to 8 minus 3x. First, we need to separate. So we will have x minus 4 equals to 8 minus 3x positive. Then we have x minus 4 equals to negative 8 minus 3x. Then we settle one by one. We will have here is for x equals to 12 and x equals to 3. Then we have here is x minus 4 equals to negative 8 plus 3x. And we will have negative 2x equals to negative 4, x equals to 2. Okay, before we conclude that x equals to 3 and x equals to 2 is the answer, we must first check either x equals to 3 and x equals to 2 satisfy the equations. Okay, let's check. First, we substitute x equals to 3 into the questions, which is modulus 3 minus 4 equals or not with 8 minus 3 times 3. So left hand side we have modulus negative 1, while right hand side we have negative 1. Modulus negative 1 is 1, but right hand side remain as negative 1. So that means x equals to 3 does not include in the answer. Okay, so let's check with x equals to 2. So when we substitute, we will have modulus 2 minus 4 equals to 8 minus 3 times 2. So modulus 2 minus 4 is modulus negative 2, 8 minus 6 is 2, modulus negative 2 is 2, 2 equals to 2. So this is satisfied, so answer here is x equals to 2 only. So before we jump to conclusions, for absolute values equations, we must check it first, either the answers satisfy the questions or not. For B, we have modulus 5x plus 3 equals to 2x plus 9. So separate, we will have 5x plus 3 equals to positive 2x plus 9. And 5x plus 3 equals to negative 2x plus 9. Okay, so we settle one by one. Here we will have 3x equals to 6. So x equals to 2. And here is 5x plus 3 equals to negative 2x minus 9. So 7x equals to negative 12 and x equals to negative 12 over 7. So we try to check for x equals to 2, 5 times 2 plus 3 equals to 2 times 2 plus 9. Okay, 10 plus 3 is 13 modulus. So 4 plus 9 also 13. So 13 equals to 13. So we accept x equals to 2. Next we have x equals to negative 12 over 7. Why don't you try to check either x equals to negative 12 over 7 satisfy the questions. Okay. B, x equals to negative 12 over 7 satisfy. So the answer is x equals to 2, x equals to negative 12 over 7.